Hello friends, welcome to Engineering Funda family. In this video, I'll be deriving Friis transmission formula. So first of all, you need to understand what is Friis transmission formula. See, Friis transmission formula explains trans-receiver system using antenna. So in trans-receiver system, we have transmitter and we have receiver. Here, trans-receiver system, that is there using antenna in Friis transmission formula. So here, see this transmitting antenna and receiving antenna that is apported by distance d, and let us say with this transmitting antenna we are applying PT power. So this PT power that is getting radiated by this transmitting antenna, and here this transmitting antenna that will be radiating EM waves in the space. So you can observe here this transmitting antenna that is radiating EM waves, and these EM waves are received by this receiving antenna, right? So first of all, what I'll be doing is I'll be considering this transmitting antenna as a isotropic source. So as if this transmitting antenna is isotropic antenna, then it will be radiating equally in all the direction, right? So here, see this transmitting antenna that is isotropic antenna, so it will radiate equally in all directions, right? As if it is radiating equally in all the direction, then what will be power density at receiving antenna? That power density will be transmitted power divided by area, right? So average power density, that will be amount of power that is transmitted over here divided by area. And here, see, we are considering isotropic source as a transmitting antenna. So equal power that is getting radiated over here. So radiation pattern that will be sphere over here. So here, see, spherical radiation pattern will be there with isotropic antenna. So with sphere, what is this area? This area will be 4 pi into square of the distance, right? So average power density that will be PT divided by 4 pi d square. So average power density of EM waves at receiving antenna will be PT divided by 4 pi d square, as if transmitting antenna is isotropic antenna, right? Now, as if I consider this receiving antenna that is having effective area AE, then how much power that is getting received by this receiving antenna? Average power density into effective area of receiving antenna, right? As if effective area of receiving antenna is AE of R, then how much power is received over here at receiving antenna? That received power, if I say that is PR, then that will be average power density at this receiving antenna into effective area, that is AER. And average power density is PT divided by 4 pi d square into effective area of receiving antenna, that is received power over here at receiving antenna side, right? But here we have considered isotropic antenna as a transmitting antenna. But what if you have some other antenna? Let us consider this transmitting antenna that is some other antenna, and that other antenna is having gain GT towards receiving antenna. See here, if I consider other antenna over here, then let us consider gain in this direction, that is GT. So as if gain is GT, then received power over here that will be this power into gain GT, right? So received power in case of GT gain of transmitting antenna will be this power because of isotropic source into gain GT. Now here, see, we have received power in form of effective area of receiving antenna, right? Usually for long distance communication, we use antenna as a parabolic reflector antenna. So as if I consider receiving antenna as a parabolic antenna, then one should know gain of receiving antenna. See, if I consider this receiving antenna as a parabolic dish antenna, then gain of receiving antenna is 4 pi effective area of receiving antenna divided by lambda square. So here we have receiving power, in that we have effective area of receiving antenna, right? So you can have this equation in form of receiving antenna's effective area, right? So if I say effective area of receiving antenna, that as a main term, then that will be gain of receiving antenna into lambda square divided by 4 pi. Now just substitute this in this main equation. So we will be having received power, that is Pt by 4 pi d square into this effective area of receiving antenna, that is Gr into lambda square divided by 4 pi into Gt, right? Now see, in Friis transmission formula, we are dealing with to identify ratio of received power with respect to transmitted power, right? So here we will be having GTGR in numerator. Let me write it GTGR in numerator, and in denominator you see we will be having 4 pi square d square and divided by lambda square will be there, right? So here in denominator we will be having 4 pi d by lambda whole square, and this is Friis transmission formula, which explains relation in between received power and transmitted power. So this Friis transmission formula that explains relation in between received power and transmitted power. So you can say it gives you idea about trans-receiver system. Usually for long distance communication, we transmit higher power. Like in radar system, we will be transmitting PT in form of few megawatts, while you will be receiving very weak power. That weak power will be there in form of 10 to the power minus 12 volt to 10 to the power minus 15 volt. So before we have communication in between transmitter antenna and receiver antenna, one should know whether we have this capacity of transmission power or not, right? So see, this ratio of received power divided by transmitted power, that is established as per gain of transmitting antenna and gain of receiving antenna divided by 4 pi d by lambda square, where as if you increase this distance, then you will be having lower reception of power. Even you can say, as if you have higher gain at transmitting antenna or higher gain at receiving antenna, then also one can receive higher power over here, right? So Friis transmission formula explains you how much distance of communication is possible in between transmitting and receiving antenna. If you have higher distance, then but obviously this EM waves intensity that will decrease with respect to distance, right? So Friis transmission formula explains you up to what distance this transmitter and receiver antenna can communicate based on their circuits. I hope you have understood this relation. Still, if anything that you would like to share, then note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.